The year 2002 saw the birth of SpaceX, a company with an audacious goal to revolutionize space travel and make it accessible to all. This was a time when space exploration was dominated by government agencies, and the idea of a private company venturing into this domain seemed almost unthinkable. Founded by entrepreneur Elon Musk, SpaceX emerged with a vision to break down the barriers of cost and technology that had long confined humanity's reach for the stars. Musk, who had already made a name for himself with ventures like PayPal, was driven by a profound belief that humanity's future lay in the stars. Musk believed that space exploration was not just a government endeavor, but a crucial step in the evolution of our species. He often spoke about the importance of becoming a multiplanetary species to ensure the survival of humanity in the face of potential global catastrophes. He envisioned a future where humans could travel to Mars and beyond, establishing a multiplanetary presence. This vision was not just about exploration, but about creating a backup plan for humanity, a way to preserve our species and culture. At the heart of SpaceX's mission was the development of reusable rockets, a concept that was considered revolutionary at the time. The idea was simple, yet groundbreaking. If rockets could be reused, the cost of space travel could be drastically reduced. Traditional rockets were single-use, making spaceflight incredibly expensive and limiting the frequency of launches. Each launch required a new rocket, which meant that the costs were astronomical, and only a few missions could be conducted each year. SpaceX aimed to change this paradigm by creating rockets capable of launching, landing back on Earth, and flying again, significantly reducing the cost per launch. This approach promised to make space travel more frequent and accessible, opening up new possibilities for exploration and commercial ventures. This ambition was met with skepticism from industry veterans, but Musk and his team were determined to prove them wrong. Many experts doubted the feasibility of reusable rockets, citing the technical challenges and risks involved. SpaceX's early years were marked by both challenges and triumphs. The company had to navigate a steep learning curve, facing numerous technical and financial obstacles along the way. The company faced technical hurdles, financial constraints, and the inherent risks associated with rocket science. Each launch was a high-stakes endeavor, with the potential for both groundbreaking success and catastrophic failure. However, their unwavering commitment to innovation and pushing the boundaries of what was possible propelled them forward. The team at SpaceX was driven by a shared vision and a relentless pursuit of excellence. They focused on developing their own technologies in-house, fostering a culture of rapid iteration and learning from failures. This approach allowed them to quickly adapt and improve their designs, turning setbacks into opportunities for growth. With the Falcon 1, SpaceX's first rocket, the company took its initial steps towards making history. The Falcon 1 was a small, partially reusable rocket designed to carry small payloads into orbit. While the early launches of the Falcon 1 faced setbacks, each attempt provided invaluable data and experience. The team learned from each failure, refining their designs and improving their processes. The team at SpaceX meticulously analyzed each failure, identifying areas for improvement and refining their designs. This iterative process was crucial in overcoming the challenges they faced and moving closer to their goals. This relentless pursuit of progress would lay the foundation for the company's future success and pave the way for the revolutionary Falcon 9 rocket. The Falcon 9, with its reusable first stage, would go on to become a game-changer in the space industry, demonstrating the viability of reusable rockets and setting new standards for cost and efficiency in space travel. The development of the Falcon 9 rocket marked a pivotal moment in SpaceX's journey, a journey that began with a vision to revolutionize space travel and make it more accessible to humanity. And the future of space travel. This vision was driven by the ambition to reduce the cost of space missions and to create a sustainable model for space exploration. This two-stage rocket, named after the Millennium Falcon from Star Wars, was designed from the ground up with reusability in mind. The idea was to create a rocket that could be launched, recovered, and launched again, significantly cutting down the costs associated with space missions. It represented a radical departure from traditional expendable rockets, promising to drastically reduce launch costs and increase access to space. Traditional rockets were single-use, discarded after each mission, but Falcon 9 aimed to change that paradigm. The Falcon 9's design philosophy centered around simplicity and efficiency. Every component was meticulously crafted to ensure maximum performance with minimal waste, embodying the principles of modern engineering. It featured a two-stage architecture, the first stage, responsible for lifting the rocket through the Earth's atmosphere, and the second stage, carrying the payload to orbit. This separation of duties allowed for optimized performance at each stage of the journey. Both stages were powered by SpaceX's own Merlin engines, which were designed for reliability, performance, and the ability to be reused. The Merlin engines were a marvel of engineering, capable of multiple restarts and designed to withstand the rigors of space travel. From its inception, the Falcon 9 was envisioned as a family of rockets, with different versions tailored to specific mission requirements. This flexibility allowed SpaceX to cater to a wide range of missions, from satellite launches to resupply missions to the International Space Station. The initial Falcon 9 V1.0 made its debut in 2009, followed by several iterations that saw significant improvements in performance and capabilities. Each new version brought enhancements that made the rocket more powerful, more efficient, and more reliable. Each iteration incorporated lessons learned from previous flights, showcasing SpaceX's commitment to continuous improvement. The company meticulously analyzed data from each mission, using it to refine and enhance the rocket's design. The evolution of the Falcon 9 has been a testament to SpaceX's iterative design process and relentless pursuit of reusability. The ability to land and reuse the first stage of the rocket was a game-changer, setting new standards in the aerospace industry. With each launch and landing, the company gathered valuable data, refining the rocket's systems and pushing the boundaries of what was possible. The successful landings on drone ships in the ocean were particularly noteworthy, demonstrating precision and control. This iterative approach allowed SpaceX to rapidly develop and improve the Falcon 9, transforming it from a promising concept into a reliable and reusable workhorse of the space industry. Today, the Falcon 9 stands as a symbol of innovation and progress, paving the way for future space exploration and the eventual goal of making life multiplanetary. The Falcon 9 is a marvel of modern engineering, a testament to SpaceX's commitment to innovation and pushing the boundaries of space technology. Its design reflects a deep understanding of aerodynamics, propulsion systems, and the unforgiving environment of space travel. Every element, from the shape of its fairing to the arrangement of its engines, has been meticulously crafted to maximize performance and efficiency. The Falcon 9's fairing, for instance, is designed to protect the payload during ascent, ensuring it can withstand the intense aerodynamic forces encountered during launch. At the heart of the Falcon 9 lies its propulsion system, consisting of 9 Merlin engines arranged in a distinctive octaweb pattern on the first stage. These engines, designed and manufactured by SpaceX, burn a mixture of liquid oxygen and rocket-grade kerosene, RP-1, generating an immense amount of thrust to propel the rocket skyward. The Merlin engines are known for their reliability and efficiency, which are critical for the success of each mission. The use of liquid fuel provides a high level of control over the engines, allowing for precise adjustments during flight. This precision is essential for navigating the complexities of space travel and ensuring the rocket follows its intended trajectory. The Falcon 9's two-stage design is crucial to its reusability. The first stage, equipped with the 9 Merlin engines, does the heavy lifting, carrying the rocket through the densest part of the Earth's atmosphere. This stage is designed to withstand the intense pressures and temperatures of launch. Once its fuel is expended, the first stage separates and begins its controlled descent back to Earth. This descent is carefully managed to ensure the stage can be recovered and reused in future missions. Meanwhile, the second stage, powered by a single Merlin engine optimized for vacuum operation, continues the journey to orbit, deploying its payload with pinpoint accuracy. This stage is crucial for delivering satellites and other payloads to their designated orbits. The Falcon 9's structure is a testament to lightweight, yet incredibly strong materials science. Its cylindrical body is primarily composed of aluminum-lithium alloy, a material known for its high strength-to-weight ratio, making the rocket lighter and more efficient. This material choice is critical for maximizing the payload capacity and overall performance of the rocket. The interstage, connecting the first and second stages, is made of carbon composite, further reducing weight while maintaining structural integrity. This component plays a vital role in the seamless separation of the rocket stages during flight. This emphasis on lightweight construction allows the Falcon 9 to carry heavier payloads to orbit or travel further into space. The ability to transport larger payloads opens up new possibilities for scientific research, commercial ventures, and deep space exploration. The Falcon 9's design and capabilities represent a significant leap forward in space technology, paving the way for future missions and the continued exploration of the cosmos. With each successful launch, SpaceX moves closer to its goal of making space travel more accessible and sustainable for future generations.